Virtual private networks have been under attack by hackers lately, especially given the increase in more employees working from home. Why? Let's start with a history lesson. VPN technology has been around for 25 years, dating back to 1996 when a Microsoft developer started developing point-to-point tunneling protocol, also known as PPTP, and later joined forces with other organizations such as Ascend Communications, US Robotics, and Ericom to make PPTP a standard for dial-up remote access. I know this history all too well because I was one of the engineers at US Robotics working on this protocol back in 1996. Over the years, other VPN technologies evolved such as L2TP, MPLS, IPsec, and SSL VPNs. I witnessed these evolutions as well, while serving as an executive at NetScreen. At NetScreen, we acquired a company called Neoterras, a company that made SSL VPNs popular back in the year 2000. Interestingly enough, and over 20 years later, VPN technologies haven't really evolved much. This has created a huge problem for remote access, as we now live in a COVID-19 era where more and more workers are accessing networks and applications remotely. Outdated VPN technologies are riddled with security vulnerabilities and are not able to provide the granular level of access security that organizations need today. Because of this, startup companies have started to pop up overnight, creating new types of VPN technologies, some of which are called SDP, software-defined perimeter, and/or zero trust network access. The challenge with these new solutions are that they require organizations to rip out and replace VPN investments that organizations have made over the last 25 years, which can become costly and time-consuming to do. Hello, my name is John Peterson. I'm the Chief Product Officer at Ericom and the inventor of some exciting new technology that I'm going to introduce to you today. Here at Ericom, we think there is a better way. We're disrupting the newly formed SDP and ZTNA market by introducing a revolutionary approach. We believe that organizations need a bridge strategy that allows them to keep their existing investments in VPN technologies while adding modern-day zero-trust security controls to them through integration. Combine the old with the new and make them better together. We call our solution the Ericom Isolation Platform. So let's take a look at the system architecture and remote access process flow. In this example, we have a remote user named John who has a VPN client on his device, and he's connecting like he normally does to a firewall VPN that exists in the network. This could be a firewall VPN from the likes of Checkpoint, Fortinet, Palo Alto Networks, or OpenVPN. The user connects as normal, establishes a VPN connection, and then the firewall VPN sends its log messages to the Ericom Application Isolator, which consists of two components, an access controller and an isolator. The access controller extracts those log messages and pulls out some important information: the username, John, the public IP address that John may be coming from, and then the private IP address that the firewall VPN has assigned to John. It parses that information out and then looks up in its local database for the applications that John is allowed access to. In this example, John is allowed access to the SAP server. So the database returns the destination IP address of the SAP server as well as the destination port and the protocol. And then the access controller takes the VPN log information and the application information, puts those two pieces together and constructs a policy. Once that policy has been constructed, the access controller pushes that policy to the isolator, which sits between the user and the applications. The isolator has a default deny policy, but the dynamic policy that is pushed to the isolator is what allows John access to the applications that he's been authorized to access. So this example, user John is going to be able to access the SAP server, but he's going to be disallowed access to the Exchange server and the Linux server. Whereas other users like Carol, David, and Nick will have completely different policies once they log into the firewall VPN device. If a hacker tries to gain access to the network, he may be able to penetrate the firewall VPN because of some sort of vulnerability in that firewall VPN, but because the isolator sits between the outside network where the users reside and the applications, the hacker will not be able to get through the isolator because the hacker will not be in the authentication and authorization database. So let's expand this picture a little bit so we get a better understanding how everything actually works. So step number 1, the user connects to the VPN. Step number 2, the user authenticates with that VPN. Step number 3, the access controller does a database lookup to the authorization database for that user. Step number 4, the access controller sends a policy to the application isolator, which sits between the user and the applications. Step number 5, the user can access only authorized applications, in this example, the SAP server. Step number 6, the user disconnects from the network. And step number 7, the Ericom Application Isolator solution removes the policy for that user, and the system goes back into a default deny state. Now, up until this point, we've been talking about remote users coming into the local area network from the outside. But the Ericom Application Isolator solution also works for users that are already inside the network. We call this east to west access, whereas the remote access solution is more of a north to south access solution. So let's talk a little bit about how east to west works when the user is not connecting to the firewall VPN at all. So in this example, we have a user, Nick. Nick is in the office, and Nick turns on his computer and logs into the network like he normally does. He's authenticated with an Active Directory server inside the network. Once he's authenticated with that Active Directory server inside the network, that Active Directory server is then going to send log messages to the Ericom Application Isolator solution, and it's going to go through the exact same set of processes that we discussed a moment ago. So let's run through that one more time. User connects to Active Directory. Active Directory sends its log message to the Ericom Application Isolator. The Ericom Application Isolator does a database lookup to find out what applications user Nick is allowed access to, and then a dynamic policy is then pushed to the isolator, and in this example, Nick is allowed access to the Exchange server but disallowed access to everything else. Now that we understand the process flow, let's start by doing a quick demonstration on how things work. Step 1, 2, and 3 can be seen in a different video, but let me explain step 1, 2, and 3 at a high level. Step 1 is to install the Ericom Access Controller. The Access Controller is the part of the solution where you configure policies and administer users. Step number 2 is to install the Ericom Isolator and place it in front of the applications that you're trying to protect. The isolator will sit between the user and the applications. Step number 3 is to configure your existing VPN solution to send its logs to the IP address of the Ericom Access Controller. Once you've completed steps 1, 2, and 3, it's time to move to step number 4 and add a software license to the system. If you don't have one, there's no need to worry. You can use the basic version free for life, but for now, I will add a license to unlock the full features of the product. Once the license is added, it's time to move to step number 5, which is to connect the isolator to the access controller. You simply give the isolator a name. You plug in the IP address that you will have configured for the isolator when you did the installation of the isolator. And then you give it the password that the access controller is going to use to securely communicate with the isolator, and you click Save. You'll notice that the last status says unknown. Give it about 10 seconds or so, and it should transition to an OK state like you've seen here. To ensure everything is working successfully, you can click on the isolator name, and the controller will query the isolator and download all of the rules that are currently installed on the isolator. And as you can see here, the default rules number 1 and 2 are installed to allow UDP port 67 and 68. These default rules are simply there to allow DHCP traffic to flow through the isolator without having to go through the zero trust authentication process. After the isolator is successfully communicating with the access controller, it's time to move to step number 6, which is to review and change default settings in order to activate something called learning mode. So let's click on the General Settings tab. In the General Settings tab, you can change the log level, where logging information can be normal logs, or you might want to change the logging level to debug if you're trying to troubleshoot some sort of problem. And then more importantly is this feature here called Auto Add Users, which is on by default. What this simply means is that any user that successfully authenticates with your VPN solution, those users are going to be automatically added to the access controller. So this negates the need for you to have to manually configure all of your users on the access controller or try to connect your access controller to some sort of identity access system like Okta or Ping or Active Directory. The access controller is going to capture all the successful login information from users and then build its own user database automatically based on what it's seeing from those VPN products it's talking to. There's a setting here that says mark a new user that it's detected as a new user for the period of 1 month. So treat any new users as a new user for 1 month. If it's a month and a half later, the user is no longer going to be treated as a new user and therefore no longer going to be a part of the new users group. The reason that this is important because the system can be configured to automatically learn what applications users are accessing when they're in this new user state. So here's a setting. We're going to keep the default, but it's going to automatically learn new users and their applications that they're accessing for a period of 1 month. So we're just going to click Save here because we're going to keep the default settings, and then we're going to move on to step number 7, which is to enable the application learning mode policy for new users. So let's go ahead and click on the Applications tab. And as you can see here, there's a policy that's already in the system by default called Everything for New Users. Let's go ahead and edit that policy and take a look. Now you notice that this policy is installed, but it's not enabled. And this policy is set to allow access to all destinations and all ports. And it's assigned to the new users group. So if we enable this policy, what it simply does, it allows all new users, those users that have logged in and have been in the system for what we configured earlier as 30 days, it's going to allow those users to have access to all applications. If the user is 31 days old, that user is no longer going to be a part of the new users group and therefore is no longer going to be able to access all applications. Now, why is it that we want to allow all new users to access all applications behind the isolator? Well, the reason we want to do that is because we put the system in learning mode. So when you newly install the isolation platform solution, it's very, very difficult to try to figure out what applications users need to have access to. So what organizations typically do is they set up user groups, and they might have the sales group access these sets of applications and the marketing group access a different set of applications. The problem when you do a group type of model is there's always going to be a user inside that group that has access to something that he should not have access to. So the only way that you can really get down to real zero trust access control is to have policy on a per user basis. But the challenge is if I have an organization of 10,000 users, how do I know what applications users are supposed to be accessing? So the way that you solve that problem is to put the solution in learning mode and allow access to all applications for the period of 1 week, 2 weeks, a month, or 2 months, or whatever you decide you want to do. And the system will then learn what applications users are accessing over time. And after the learning mode period is expired, the system will propose a policy set for the administrator to approve and accept. Once you've approved and accepted that policy, the system goes into a default deny mode, denying access to all applications and only allowing access to those things that the policy has dictated. This capability is a unique differentiator for Ericom. We call this learning mode, and it's something that we have patent pending. So now that learning mode is enabled, let's move on to step number 8 and allow your users to connect and access the network like they always have. They will simply connect in via VPN that VPN system will then talk to the access controller and tell the access controller that the user logged in. And then the access controller will tell the isolator to allow the new users to access all applications behind the isolator. And then meanwhile, as those users are accessing those applications, the isolator is monitoring all of the applications that the users are accessing and reporting back to the access controller the time and day the application was accessed, the username that accessed that application, how much data was transmitted to the application, and where the user was accessing the application from. For example, San Francisco, California. And then after all of this is done, the system will propose a policy for the administrator to approve. So let me do a demonstration really quickly of how a user is going to access the system. Okay, so we're at step number 8. Allow your users to connect and access the network like they always have done before. Let's take a look at the user tab so we can show that there are currently no users installed on the system. It's a brand new system, no users, and all we have is one policy that it says allow all for new users. Again, keep in mind that we enabled auto adding of users and marking them as a new user for 30 days. So we have no users right now. But what I'm going to do is bring up a VPN connection using my open VPN client that you can see here. And then I'm going to log into the VPN. And now that I'm connected, I'm user JP, and I have a IP address on the local area network of 10.8.0.4. And I'm connecting to this VPN server here, 54.215.32.147. Now let's go ahead and refresh the users section to see if it's automatically discovered that user. And there we have. We've discovered a user called JP, and JP is marked as a new user until August 28th, 2020. That's 30 days from today, because today is currently July 28th, 2020. Now this new user JP that's VPN connected should now then be able to access applications as dictated by the application policy, everything for new users. And the system should monitor the applications that user accesses and propose a policy. Let's take a look at that. Okay, so I'm currently VPN connected to the network as user JP. Again, my IP address is 10.8.0.4, and I'm going to try to access an application on the network. So let's go ahead and try to SSH to one of my servers. And as you can see, I'm currently connected to my server using SSH. Let's try to connect to another application. How about connecting to an RDP host? And as you can see, I've connected to my RDP host. Now let's take a look at the Ericom access controller to see if it's actually learned those applications that I've connected to and associated that connection with user JP. Okay, by clicking on Learning Mode, I can see here that there are two applications. Microsoft Terminal Server, that's the machine that I RDP'd to, and then SSH Remote Login, that's the machine that I SSH to. If I click on Associated Users, it's saying that user JP accessed that RDP application 6 times. And if I take a look at the SSH application, it's showing that user JP has accessed that application 4 times. So what I can do here is I can take this policy set that's been proposed to the administrator by the system and approve it or disapprove it. So let's click on Associate Users, and I'm going to say yes, user JP is allowed access to this application. And then I'm going to click on Learn It, and then I'm going to save this policy. Now if I click on Applications, you'll notice that the SSH Remote Login Protocol application is now part of the policy set. And if I take a look at the attributes of that, you'll see that user JP is the one that's allowed access to that application. Okay, so now based on the policy table that I have here, I have the SSH remote login protocol application, and just look at it one more time. It's assigned to user JP and only user JP. And I still have this other policy here that we enabled for learning mode, which allows access to everything for all new users. Why don't we go ahead and disable this policy? So now the only policy that's active is this SSH remote login protocol policy for the user, take a look one more time, JP. So this time I'm going to disconnect my VPN connection, and instead of logging in as user JP, let's log in as user David. Okay, now we're connected as user David. And because I have auto learning of users still enabled, it should learn that user David's a new user. And as we can see here, user David's a new user. But if we look at the policy, keep in mind we disabled this allow everything for new users. So David should not be allowed access to anything. He should not even be allowed access to the SSH server, because the SSH server is only assigned to user JP, not user David, which was just learned by the system. So let's prove that that's the case. And as we try to SSH that same server, 10.198.3.229, you'll notice here that user David is not successfully accessing that server. Let's find out why. Again, if we go back and look at the applications, we'll see two policies. Everything for new users is now disabled, so the allowing access to all applications does no longer exist. There is one policy here that's called SSH remote login. That's actually the server we're trying to log into. But you'll notice here that the only users that are assigned to this policy is user JP, not user David. This is zero trust access controls at a per user basis, and the policy was automatically learned by the system and approved by the administrator. If I were to go ahead and change this policy and then add David, click Save, and then go ahead and disconnect my VPN connection and log back in as David, you'll see that I'll be able to access the application. Let's go ahead and try that. Okay, so I'm logging back in as user David after I've updated the policy. User David's now connected. And now let's go ahead and try accessing that application. And as you can see here, user David now has access to this application. Let's go ahead and take a look at the isolator and see what policies are actually on the isolator that allows David to access that SSH application. I can simply do that by clicking isolators and clicking on the name, and you'll notice that I have those default policies that I mentioned at the beginning of this video session that are still in place. These are the ones that allows DHCP access. And notice there's a role called 1004, which is allowing user David access to the SSH application. It looks like user David has an IP address of 10.8.0.3. We can confirm that by looking at the VPN client, and you'll see here user David has an IP address of 10.8.0.3. Once I disconnect, this particular policy is going to be removed from the isolator. And after I've disconnected, if I were to refresh this page and then click on the isolator name, you'll notice that that policy 1004 for David is no longer on the isolator because user David has logged off and is no longer connected to the VPN system. Okay, so we just completed step 9, which was to review the policies that were automatically learned by the system and approve them. And then step 10, which was to take the system out of learning mode and let users access things in a restricted zero trust manner. User JP was allowed to access everything at first because he was a new user and he matched the new user policy. He was able to SSH into a server and RDP into another server, and the system proposed those as two policies. I accepted the SSH policy but did not accept the RDP policy. And then user David was not allowed to access anything until I manually added him to the policy set. So step number 10 was to take the system out of learning mode and let it operate normally. When the system is operating normally, there's a number of other things that you can do. You can actually go to the usage section and go ahead and take a look at the log data that the system has actually collected as it relates to users and applications, where they're VPNing into the network from, how much data they're transmitting, and a number of other things. So let's take a look at that. Here in the usage logs, you can see that user JP has had a number of log on and log off events, as well as user David. You can also see that user JP has been logging in from Redding, California. User David was logging in from San Francisco, California. I can also scroll down and see what applications users were accessing. User JP accessed the Microsoft Terminal server and the SSH server. And then user David was accessing the Microsoft Terminal server and the SSH server as well. You can also see failed connections that user JP and user David attempted to access. And you can actually get a breakdown of how much data was actually transmitted to those applications, and then where the connections to those applications were coming from. On the main dashboard, the globe that's spinning here is actually showing active logins. So as we wait here, you'll see the globe spin around, and you'll see that there's an active VPN connection currently from California. And as you can see here, the dot here on the globe represents a connection that's active right now from Silicon Valley out here in California. So this concludes our 30-minute demonstration and architecture overview of the Ericom Application Isolator. As you can see, with 10 easy steps, you can take your existing network and turn it into a zero trust network with hardly any friction at all. So what's next? You can run a simple POC for a portion of your users. You can evaluate the simplicity of deployment and the user experience and the benefits you gain from the solution. And then you can work with the Ericom sales team to discuss how we can evaluate the business case that you have and broaden adoption. Thanks, and I hope you guys enjoyed this 30-minute video.